Hello, this is P.V. Sudarshan from the Department of Chemistry. In today's session, we will be discussing on chemical equilibrium and hydrogen. First question, which of the following is an irreversible reaction? First of all, what do you understand by an irreversible reaction? An irreversible reaction is that which proceeds in only one direction. I am repeating, an irreversible reaction is that which proceeds in only one direction. Now your options that you have: neutralization of a strong acid versus strong base, neutralization of a weak acid versus strong base, neutralization of a strong acid versus weak base, and the last option, neutralization of a weak acid versus weak base. An underlining statement for you to know about irreversible reaction: neutralization of a strong acid versus strong base is always an irreversible reaction. Let me give you this important point. Neutralization of a strong acid versus strong base is always an irreversible reaction. In the neutralization reaction, you are aware neutralization reaction is a reaction of an acid with a base to give salt and then water. If one of the reactant, that is either the acid or the base, is weak, then it is a reversible reaction. Now we will judge what is the right answer. Option A, neutralization of a strong acid versus strong base. Obviously, this is said to be an irreversible reaction. Just to confirm what the statement that I made: neutralization of a weak acid versus strong base, acid is weak, understood that it is a reversible reaction. Option C, neutralization of a strong acid versus weak base, base is weak, it is a reversible reaction. And I said, if either of the acid or the base or both the reactants are weak, it is a reversible reaction. Therefore, the correct and right answer is option A, neutralization of strong acid versus strong base is the correct answer. Option A is the right answer. Our next question, for the reaction A plus 2B giving 3C, the equilibrium constant Kc is given by. Let's understand how to write equilibrium constant. You are aware that equilibrium constant is written for a reversible reaction. I write a reversible reaction where Na plus Mb is giving me Xc plus Yd. I understand that A and B are the reactants, C and D are the products, N, M, X and Y are the number of moles of A, B, C and D respectively. When I try to write the equilibrium constant for this, it is written as Kc equilibrium constant with reference to the concentration is written or is defined as product of the molar concentration of the products raised to its stoichiometric coefficient divided by product of the molar concentration of the reactants. Meaning, I write it like this. First I write the concentration of the products. Therefore, I write concentration of C to the power of X, concentration of D to the power of Y divided by concentration of A to the power of N, concentration of B to the power of M. Therefore, Kc equilibrium constant is written as product of the molar concentration of the products raised to its appropriate powers by product of the molar concentration of the reactants raised to its appropriate powers. Now, keeping this in mind, let us try to solve the above question. A plus 2B giving rise to 3C. I understand that Kc is written as product of the molar concentration of the products. That is, I have only one product, that is C. I write it as concentration of C raised to the power 3 times. In the option that is given here, option A, I have concentration of A and B ruled out. Option B, I have concentration of C, let me keep it aside. Option C, I have 3 times concentration of C ruled out. Option D, also I have concentration of C raised to the power 3 times. Therefore, by right probability would be option B and option D. Now, how do I come back to judge which is the right answer? When I look into this again, divided by product of the concentration of the reactants. I have concentration of A raised to the power 1 time, yes. Concentration of B raised to the power 2 times. Therefore, option B happens to be the right answer. The correct answer is option B, that is concentration of C raised to the power 3 times by concentration of A raised to the power 1 time into concentration of B raised to the power 2 times. Our next question, for the dissociation of hydrogen iodide, the equilibrium constant is found to be 0.25. What would be the equilibrium constant for the formation of hydrogen iodide? A simple basic concept in chemical equilibrium. Whenever the equilibrium constant of a forward reaction is given, the equilibrium constant of the backward reaction is reciprocal of the equilibrium constant of the forward reaction. I mean to say it like this. For the dissociation of hydrogen iodide, I write the equation of dissociation of hydrogen iodide. Hydrogen iodide undergoes dissociation to form hydrogen and iodine. I have written it. It's been given the equilibrium constant of the forward reaction happens to be 0.25. Now, he is asking me what would be the equilibrium constant for the formation of hydrogen iodide. I just mentioned this concept. Equilibrium constant for the backward reaction is 1 by the dissociation constant of the forward reaction, meaning I write it like this: equilibrium constant of the backward reaction is equal to 1 by KFR. This would be 1 by 0.25, which would be, hope you know how to do this calculation, 1 by 0.25, it is 100 by 25, and your answer happens to be 4. In the options that we have, option A 4, option B 3, option C 2, option D 1. The right answer is option A 4 is the equilibrium constant for the formation of hydrogen iodide. Our next question, for an exothermic reaction, option A, K is independent of temperature, option B, K increases as temperature increases, option C, K, that is equilibrium constant, decreases as temperature increases, option D, K varies with addition of reactants. Let's try to understand what are the factors that govern the equilibrium constant. The value of equilibrium constant is independent of Number 1, concentration of reactants. Number 2, volume. Number 3, change in pressure or presence of a catalyst. It is independent of all these factors, while the value of the equilibrium constant is fixed at a given temperature and it varies for an endothermic and exothermic reaction. Now, the question is for an exothermic reaction. I'd like to mention this. For an endothermic reaction, the value of K increases with increase in temperature, while for an exothermic reaction, the value of K decreases with increase in temperature. This is the concept you need to know. I am repeating, for an endothermic reaction, the value of K, equilibrium constant value, increases with increase in temperature, while for an exothermic reaction, the value of equilibrium constant decreases with increase in temperature. Therefore, judge which would be the right option. Option A, K is independent of temperature, not relevant. Option B, K increases as temperature increases. This could have been the answer if it was an endothermic reaction, but because it is an exothermic reaction, K decreases as temperature increases. Therefore, option C is the right answer. Option C, K decreases as temperature increases, is the correct answer. Our next question. For the reaction N2 plus 3H2 gives 2NH3, the value of equilibrium constant depends on option A, initial concentration of reactants, option B, pressure, option C, temperature, and option D, all of this. In the previous question we had discussed that the value of equilibrium constant is independent of the initial concentration of the reactants, nor volume, or changes in pressure, or presence of a catalyst, or presence of an inert material, while it is dependent on the nature of the reaction, whether it is an endothermic or an exothermic reaction. There also the equilibrium constant varies as the temperature varies. Therefore, we have understood that for an endothermic reaction, equilibrium constant value increases with increase in temperature. For an exothermic reaction, equilibrium constant value increases with decrease in temperature. Therefore, the governing factor for the equilibrium constant is temperature. Option C, temperature, is the right answer. Our next question. This question is a recap of the previous two questions that we have done. If you do it correctly, understood that you have understood the concept of equilibrium constant. Therefore, I have added up a similar question of what you have discussed. For an endothermic reaction at equilibrium, the formation of product can be increased by option A, increasing temperature, option B, lowering temperature, option C, keeping the temperature constant, option D, decreasing the concentration of reactant. So, I had been telling you for the past 5-10 minutes that the deciding factor, the governing factor to determine the value of the equilibrium constant is temperature and only temperature. The value of equilibrium constant is fixed at a given temperature. It varies depending upon the nature of the reaction. Now, for an endothermic reaction, we understand that again temperature plays a vital role, but which is the correct answer here? Is it option A, increasing temperature, option B lowering temperature, option C keeping the temperature constant, option D decreasing the concentration of reactant. We are aware this option D, decreasing the concentration of reactant, is not affecting my equilibrium constant at all, but temperature plays a vital role. Therefore, I had mentioned little while ago, by increasing the temperature, the value of the equilibrium constant increases for an endothermic reaction. Therefore, the right answer is option A, increasing temperature favors the formation of the product for an endothermic reaction. Option A is the correct answer. Our next question. For the reaction Na plus Mb gives products, in according to law of mass action, which of the following options is right? You should be aware of what is law of mass action. Law of mass action was proposed by Goldberg and Veitch. Law of mass action states that the rate of the reaction is directly proportional to the product of the active masses of the reactants. I imagine my reaction here, that is Na plus Mb is giving me products. Now applying law of mass action, I write it as rate of the reaction is directly proportional to the product of the active masses of the reactant, that is concentration of A to the power of its stoichiometric coefficient, that is N, into B to the power of M. Now, removing the proportionality sign, I introduce a constant called K. Therefore, my final expression will become now as rate is equal to K, A to the power of N, B to the power of M. This would be the right answer. Now, looking into the option A, option B, option C and option D, my answer matches to option D. Option D, rate is equal to K, A to the power of N, B to the power of M is the correct answer. Option D is the right answer. Our next question. The relation between Kp and Kc for the synthesis of ammonia, N2 plus 3H2 gives 2NH3. You are aware, you would have studied this in the theory class. Kp is equal to Kc, RT to the power of delta N, where you are aware delta N is the difference in the number of moles of the gaseous products and the number of moles of the gaseous reactants. I write it like this: Kp is equal to Kc RT to the power of delta N. All I need to do in this is calculate what is delta N. I mention now delta N is equal to number of moles of the product which are in gaseous state minus number of moles of the reactant which are in gaseous state. I understand from this that the number of moles of the product which are in gaseous state happens to be 2 minus number of moles of the reactants in the gaseous state happens to be 3 plus 1, 4, 2 minus 4 is minus 2. Therefore, when I happen to substitute, the value of delta N is equal to minus 2 in the equation, then my equation will become Kp is equal to Kc RT to the power of minus 2. Therefore, looking into the option A, Kp is equal to Kc, option B, Kp is equal to Kc RT, option C, Kp is equal to Kc, RT to the power of minus 2 happens to be the right answer. Option C is the right answer. Our next question. The equilibrium constant for the reaction SO2 gas plus NO2 gas is giving me SO3 gas plus NO gas is 16. What will be the equilibrium constant for the reaction when the above mentioned equation is multiplied 2 times? To understand this question, let's learn little bit of basics. Now, how do we attempt for this question? I write it as, imagine I have A plus B equilibrium step giving me AB. If I write the equilibrium constant of this equation is given or designated as K1. If I imply the changes to this equation, that is, I had SO2, I had this equation, I am multiplying the equation by a factor called 2. Therefore, here similarly, if I multiply this by a factor, just like that I say, by a factor called m, then my equation would be m times A, m times B is giving me m times AB. Now, I am asked to calculate what is the equilibrium constant for the written equation. The equilibrium constant is written as equilibrium constant is equal to equilibrium constant of the earlier equation, that was the reference equation or the base equation. I have it as K1. It is raised to the power number of times or the factor by which it is being multiplied. It is being multiplied m times, therefore, I write it as to the power of m. Hope you have understood this concept. Keeping this in mind, let us look into the given question. I have SO2 plus O2 giving me SO3 plus NO. This equation is multiplied by the factor called 2. I understand, therefore, my answer would be equilibrium constant for this equation is equilibrium constant for the above equation, which was my base equation. For doing this numerical, I have equilibrium constant K is equal to the equilibrium constant of the above equation, that was 16. Therefore, K is equal to 16. It is multiplied by a factor called 2. Therefore, it is raised to the factor called 2. Therefore, my right answer is K is equal to 16 square, which happens to be 256. Now, look into the option. Option A is 16, option B 32, option C 256, option D 4. I get my answer as K is equal to 256. Therefore, the correct answer is option C, 256 is the right answer. Our next question. The equilibrium constant for the reaction N2 plus 3H2 gives 2NH3 is K. Then the equilibrium constant for the given equilibrium. If you happen to look into this question, synthesis and dissociation both are being given. We have discussed this problem few minutes ago in the dissociation of hydrogen iodide and in the formation of hydrogen iodide. If the equilibrium constant of the forward reaction is KFR, then the equilibrium constant of the backward reaction, that is KBR, will be 1 by equilibrium constant of the forward reaction. Same concept is applied here. It is given like this. equilibrium constant of the forward reaction is K. I want to calculate the equilibrium constant of the backward reaction with some changes. Therefore, let me go for the basic principle. Therefore, equilibrium constant of the dissociation of ammonia would be K will be equal to 1 by K. This is the basic principle. Now, you have understood from the previous problem that whatever changes I apply to the given equation with reference to the base equation, it has to be taken as the power of so and so. Now, here this equation and this equation, if I happen to compare, every factor is divided by 2. I would say it is multiplied by 1 by 2. Therefore, my answer is K is equal to, since I have reversed it, I have written it as 1 by K to the power of, every term here is a factor of 1 by 2 multiplied by 1 by 2. I raise it as to the power of 1 by 2. Therefore, my answer is K is equal to K to the root. I hope you have understood. I am repeating, K is equal to 1 by K to the power of 1 by 2. This is nothing but 1 by root K. Therefore, 1 by root K happens to be the right answer. Now, looking into the option A, 1 by K, 1 by K2, C is root K. Option D, 1 by root K is the correct answer.